to go back here.
No one even told me until after they'd already taken off, so I would have never known.
Okay. Yesterday. Get your notes out from yesterday, please.
Why are we actually? I am upset right now. Can I go on a rant to you what I did earlier today? Here's what happened. I turned in an application earlier this year to be the student section leader. They turned it down. Okay? They gave it to Riley Ring. I shouldn't have named her. They gave it to somebody else.
Okay.
That somebody else, they asked to do the ELC thing today, and she said she didn't want to be in front of people. Then they told me to do it, and I said no. And they said there's no saying no. And I said, you said no to my application. How is there no saying no? And then they're making me do it. I don't get out of class early. No classes early. I get nothing for any of this.
You do get out of class early.
They told me I didn't.
I'm pretty sure you do.
I should have gotten out at 10:40.
No.
With ELC. ELC got out at 10:40.
That's dumb.
Why am I not
You get out at 1.
All I know is this is stupid.
Is it for the assembly?
All I know is you're eating up homework time right now.
They're going to give me an open mic, and I'm going to say some stuff that they're going to regret. They gave me an open mic.
Oh my
And
goodness.
they're playing Hungry Hippo, and some people might get hit by dodgeballs. And it wasn't me. Oh, they gave me a script. I'm not looking at it.
Okay. We talked about the fundamental theorem of calculus yesterday. Right? The fundamental theorem of calculus. So, what I would like from you, just for the sake of reviewing the things, I would like you to do the integral from 2 to 5 of 3x squared plus x minus 1. I'm recording, but I would say I would have to understand your frustration with the being told no.
And I told them no. And they said
after somebody else was like, I don't want to be in front of people, and then no. Like, you're the student section leader. Yeah.
Guess who goes to all the games, but they don't? Me. I am beyond myself with this whole thing. Yeah, I'm not even looking at the script the entire time. I'm not looking at the script the entire time. You know what I'm gonna do? Oh, she's
Just try not to laugh at you out loud. Sorry. Please use a fundamental theorem to find this. Also, I would like to say this is another really nice use for that table in your calculator where you can do the auto and you can switch it to ask. Because you can just type this into your calculator and then find the 5 and the 2 real fast. I'll show you what I mean in a minute.
I'm still so bad at that. I'll try and figure it out. I can't already.
Bless you. A little bit. It would if it was a big long one.
Well, since it's only 5 and 2, I can just look at 5 and 2, right?
Mm-hmm.
Plug it in. I don't need to even do the ask.
Yeah, because it should have 5 and 2 on there.
Yeah, they're like pretty close.
Yeah.
I fear I might have plugged this in. What did you guys get for 2? Was it nice?
Yeah, 2 was nice. 5 was not.
I got 107.5.
Oh.
I got 132.
I got
Shouldn't be bad.
Yeah. Oh, I got 3,115 over 2.
Oh.
Well.
My ending answer got 99.5.
Interesting.
Oh, yeah, no, this is not the right.
Okay, so What is the antiderivative? Because fundamental theorem says do the antiderivative.
X cubed plus half x squared minus x.
Minus x. You're going to plug in a 5. You're going to plug in a 2. So what I was saying about the calculator, if you want to, just pop this. You have to pop your antiderivative into y equals. So x cubed plus 0.5 x squared minus x. And then go to your table, right? It's table set where you switch that to ask. But you don't have to, like your regular table will have 5 and 2, but I just like to not have the crap, right? So 132.5 minus 8. So final answer would be 124.5.
How do I get it to give me just? It might give me a fraction. So I got the right answer. It's just took me a while.
Put a decimal point, I don't know, just get this word.
How'd you get that?
You go 5 point or whatever, in the category, it'll give it to you.
Miles, how'd you do on that?
Better than Raquel.
What?
On the chemistry test.
What'd you get?
So
How long was that?
What was our average? I think that's like a 68.
Caleb, did you ask how?
I subtracted it, so that I got it.
Okay. Okay.
Easy there, David.
Like lower than
The average was 64.
Do you?
She's grading it like 80 tests.
Do you have any questions on the fundamental theorem? It's pretty easy. I got to add a couple other things that we need to talk about. Okay, so Garrett and Ashley, you might want to put your calculators down.
I'm trying to figure out the stat about this thing. It's related to this.
Oh, you want to shut it off?
Right now, I should be studying my.
Do you want to? No. Do you want to shut the stat plot off?
My script, but
I
I'm
was
doing
doing
that
that
with
the
my
whole way, and I'm just testing the stat line.
Got it. Got it.
Okay, just.
I thought you were telling Garrett to turn his calculator.
No. I was asking if he needed to turn the stat plots off. Okay, so
You don't realize what this brain does.
we're going to talk about something called symmetric integrals, which sounds like it's terrible, but it's not. This gives you a shortcut option. Okay, it's a very limited shortcut option, but it is worth paying attention to. Okay.
You tell me how I do it.
Oh,
I'm just looking at the script every once in a while. Let me know how
okay. So this is a symmetric integral. Okay. Why do you think they would call it a symmetric integral?
Because it uses the positive, negative.
Use a positive and negative of the same number. So like if you were going from 1 to -1 or 2 to -2, okay, that's the symmetric. It's on the same side of the same integrals on either, whatever, the numbers on either side of the y-axis. There we go. Okay, now, symmetric integrals, there's two possible shortcuts here. One of them I use a lot and one of them I never use. Okay, so what I want you to do is I'd like you to do, just kind of off to the side or whatever, we're going to leave yourself some space because I'll give you the shortcut. We want you to do the integral from, we're going to try to make your life really nice here, -1 to +1 of, just a second, my brain not working.
You got it.
Oh no, I can't do it. X cubed. I know that was rough. X cubed dx. I was trying to make it so there was no fractions and it wasn't going to happen. Sorry. Okay, I'd like you to do, find the integral. Do the fundamental theorem. I don't want that one. Like I need a specific function.
I got it.
Okay. I want you to find the exact value using the fundamental theorem.
you're right, I was wrong.
Plus or minus.
You gotta, I want the final answer.
Wait, is that just gonna be?
Zero.
It's just gonna turn into zero.
Go for it.
No, mom is.
But you got a negative one for it, and then a plus
Yeah,
one
it's
for it.
No.
Did you put it in that spot?
I think one of
What
your.
are you doing?
I think one of your. I think one of your negatives probably didn't carry here.
Like, just think about it logically.
I just randomly said
It's zero. It's going to be zero. A number minus, or a number plus the negative of that number is always going to be
Yeah. Okay, that's not a step.
Genius.
It just says that was right.
Yeah.
Is that right?
But yeah, top number, subtract.
Okay.
You gotta, that's the fundamental theorem. You have to subtract the top number minus bottom number. Okay,
Oh, I'm tweaking.
Yeah, that's 1/4 minus 1.
No, I'm the one.
what's the answer?
I know you are.
Zero.
Zero.
Yeah, but it's minus, not plus.
What's the antiderivative?
1/4 x to the 4th.
1/4 x to the 4th. You're gonna plug in a 1. You're gonna plug in a -1. I tried to make it nice, why it's ones, right? So when you plug in 1, it's 1/4. And when you plug in 1, -1, what is it? Also 1/4. And so what is the answer? 0. Now, I want you to think about this. Actually, I'd like you to do this one also. Why don't you do the integral from -2 to +2 of x to the 5th?
Are they always gonna be zero?
Yep.
Well,
It's definitely.
No, you're on for
What
it.
if it's an odd exponent?
Yeah.
Then it could
Give it a shot.
maybe not be zero.
Here's the thing though, so we're not gonna be a context one.
It is not. I just could make it all here.
You're talking about the
Bad
antiderivative.
comms on my part.
Remember that you have two exponents you're dealing with here. So when you say it's odd, somebody else can be like, it's odd, and be correct because it's originally odd. Yeah.
But you don't call them that. Now what are we doing?
Finding a shortcut. The shortcut
Okay.
Alright, shortcut noted.
What's the answer?
Zero.
Okay. So 1/6 x to the 6 from 2 to -2. You plug in the 2s, you divide by 6. It's something terrible, but they're the same something terrible, so it equals 0. Now,
10.6.
that's,
32 over 3.
okay, 10.6 repeating minus 10.6 repeating. Okay.
At the end of this is seven.
Last one. I want you to do this one because you're going to think you know the answer and you don't. I want this to be x squared. So let's see if I can make your life easy. Let's go 3x squared.
Mason, I think you're overthinking it as always.
Actually, I don't think you're overthinking it. It actually, absolutely, the graph would help you out. You're welcome.
I'm just used to you overthinking.
I think you should just do this because the answer.
But she just said that the
Yeah, but if you wouldn't have said that, if you wouldn't have done that.
I'm going to tell you the answer is not 0 on this.
It's 2.
It's
It's 2, right?
I got two as well.
It's not that hard when it's an odd.
Okay, so,
0 or it equals 2. No, it equals
well, if this was from 4 to -4, it would not equal 2. No. It would be it would be 4 to the 3rd times 2. From 4 to the -4. Okay. Oh, well. Raquel, Anna, correct. Okay, so here we did. I did. So here's what I want you to consider. If we were to graph x to the 3rd, like not his antiderivative, but if we were to graph actually x to the 3rd, it looks like this. Okay? What kind of symmetry does it have? It's rotational symmetry, right? So if I were doing the integral, let's just say from -2 to +2, well, I can make them 1 and just make the scale bigger, right? The integral, the area here under the curve is positive, right? The area here under the curve is negative. But what's true about those two areas? They're equal because the graph is symmetric. Okay, so this property only happens on something called, we talked about this last year, but I know it's been a long time, on an odd function. Okay, so when it's an odd function, okay, so if it's an odd function, back to the shortcut up there, if it's an odd function, the answer is 0.
Even if it's like 4x to the 3?
Yep. So if the exponent is odd. So the other thing you need to know is that sine and tangent are also odd functions. Okay? Sine and tangent are also odd. Those don't have exponents. But listen, once you see the antiderivative of tangent, you're going to want to remember that it's an odd function, because then you don't have to do its antiderivative. You just be like, hey, it's 0. I know because it's tangent.
What if it's had transformations? Because then it's not symmetrical.
Okay, so just a second, I'll answer that question.
I think it's kind of similar, but like if it has a odd and an even exponent.
Okay, so let's talk about this shortcut. This is the one, I use this one a lot. I don't use the even one very often, okay? Because the even one's kind of lame. Useful only a little bit. So an even function would be one that looks like this.
So I'm guessing on a test it's gonna like ask for a reasoning of why.
Nope.
No.
Nope. Okay, so if I were to go from -2 to +2 on this guy, which would be x, this is x squared, it's the even function. Sorry, there you go. Okay, what kind of symmetry does it have?
Axis.
Reflection. It's reflection symmetry, right? So
Coincidence?
I think not.
I think not as well.
So these two, the two areas on the right and on the left are equal. So the shortcut for an even one is that the answer is 2 times the integral from 1 to a of an even function. Okay? It's just as much work, if you just said that. It's just as much work. The only difference is that it's really nice to plug in, I lost it. It's really nice to plug in a 0, right? To plug in a 0 is much easier than plugging in a negative number. I do not use this one very often. Just a second, Alex. I'm going to go back to those 2 questions now. And then I will answer yours, Alex. This is 0. Right there? 0.
Yeah.
So it's double. This is double the integral from 0 to a. I don't use that one very often. But, because it's annoying. Let's be real. Just a second. Just a second.
A is more than 0, then you have to split it.
Yep. Okay, A is the big.
If you did a transformation, wouldn't this?
Just a second. So,
Or can you pull it out?
just a second. Oh, let's go back to this a second. Cosine is even. Okay, so sine and tangent are odds, cosine's even. So let's say you have something like this. This is where I'm going to answer kind of Garrett's question and Mason's question a little bit. Okay. It has to be straight up all distributed out. So if the transformations were in there in parentheses, then you can't do it. Mason, that's the answer to that question. So as long as it's in polynomial form like this, where you have separate terms, you can say, hey, what's the integral of an even function? Excuse me, let me try that again. What's the integral, symmetric integral of an odd function? So you know what? You can ignore it. You don't have to do anything with it. What's the symmetric integral of an odd function? Is 0. So you can be like, you can either remember the even shortcut, which is a pain in the butt, or now you just have to do one term with the fundamental theorem.
So if it's even, then you can. What if there's like 2 even ones and you just
Yep.
put them together?
Well, like if let's say this was also like a 5x to the 4th, you still are doing the integral of 2x squared plus 5x to the fourth.
You can just get rid of all
You get rid of all the odds. That is really where I use it, is I just cross out the odd ones. Listen, so limited though, because it has to be a symmetric integral only. So don't go, like if we're integrating from 4 to 10, this doesn't apply. Okay? It's a very limited shortcut. Alex, what was your question?
You said back to that graph where it has rotational symmetry.
This one?
Oh, yeah, that one. You said that the areas are the same, but they're not.
Positive and negative though.
Yeah, positive and negative. Does that mean you do subtract the negative area?
No.
You add.
No, because it ends up, remember that when you use the fundamental theorem, okay, so if you're using the fundamental theorem, it takes care of all of the negativeness of it in itself. Okay? So you don't overthink it and be like, well, I know it's below, it's going to cancel, so I have to add the negative. Don't. Just know that if we did the fundamental theorem, it would give you this guy, it would give you this guy, and you subtract them, because remember, if you're doing the fundamental theorem, you're actually working with the antiderivative. So you're looking at two different representations. This is the picture of what this is. This is how we get it. This is the picture of what this is. So they're two different things. Mason.
So what would you do if there's like a number without an x on there, like 5?
Okay, so a number, so let's graph that. So let's say we have a 5, y equals 5 in there, even or odd. Based on its, I don't care if this is 5 or 6 or whatever, but based on its shape, does it have reflection, symmetry, or rotation? It's to the 0 power, actually, right? It's 5, that's like 5x to the 0 power, which means it's even. It has reflection, symmetry. So a constant is also even.
Well, that doesn't really do too much because
Easy to do the antiderivative of a constant. So I would just do it if it was me. But that's a good question. A constant is even. So again, this is very limited. We actually don't get homework on this until maybe the next section, but this is the place that it makes sense to put this because we're talking about integrals. Now, cross out the odd part of it. Yep. On a symmetric integral, cross out the odd part of it.
So if let's say there was an x minus 2 in there, and that, could you distribute it out? Or is that
Okay.
not allowed to be touched?
So let's say you had x minus 2 and it was to the third, like that. If you were going to do this, you would have to expand the whole mess. Like you'd have to
X
do,
cubed minus 8.
no, x minus 2, x minus 2, x minus 2. Exponents don't distribute in. So this is a chain rule thing, which we'll talk about eventually. I'd do it with the chain rule. It's easier. Okay, Aiden.
I was going to ask if we have to write anything when we do it, like to
Nope.
show that that was our process.
Nope. Not at all.
3x minus
Alright, homework, Greg.
Nope. One more thing. Okay, so this is a special condition here. We're just still talking about integrals. It does not relate to symmetric integrals. Absolute value. Okay, so let's say you're going to do the integral from 0 to 4 of the absolute value of x minus 2. Okay, so here's the deal here. We've not ever done an antiderivative of absolute value. That's because you don't do the antiderivative of absolute value. So what you're going to do when you have this is you're going to go back to a graph. You need to go back to graphical thinking. So I want you to think about this. Let's make this 6 instead, please. Okay, what is the shape of absolute value? It's a V-shaped graph, and those two V's have a slope of 1. So it's very easy to graph this. What transformation is that? Right to. It's inside the parent function. It's right to. So you are just going to draw yourself a little graph. Okay, absolute value moved right to. Looks like this. I don't know. No, it's more than 4. Originally it was 4. So this If this is 2, absolute value at 0, what's the height of that? 2. At 6, because that's where we're ending, what's the height of that? No. 4. Right? Minus 2. 6 minus 2 is 4. Okay, so this height is 4. So now what do you have? What do you have? Here. What do you have here? 2 triangles. Okay, so you go back to when you have absolute value, you default to thinking about transformations, put it on a graph, and you're going to have 2 triangles. Find their area. Okay, so we don't do, even though this is a definite integral, we don't do the fundamental theorem with absolute value because there is no antiderivative of absolute value. It's not continuous. It's not differentiable there. It's continuous, but it's not differentiable. Just, it's a mess is what it is. Quite possibly. Okay, so anyway, this guy is 2 times 2, but half of that, so this area is 2. This is 4 times 4, which is 16, but half of that is 8. So your final area is done. Okay, so if you have an absolute value, do not freak out. You graph it. Okay, so that's all I have to say about that. So your homework, which you have a lot of time to do, surprisingly. That was my goal.
That's not true. Yesterday you said we're gonna have a lot. So
I know.
I'm not surprised.
Well, she said surprised because of all the.
I was surprised we had a lot of questions, which is fine to have a lot of questions. I just thought we would have less homework time. So it's good. It's a good surprise. Okay.
Probably not. Like, I don't know, the assembly is a big.
Well, and low-key, like, it's not like our kids are.
If I see
Bill online for us.
Now that I'm thinking about it.
What could he about it would be doing here?
It's not true. Yesterday I walked in there, he had a golf ball.
I saw that.
And then I was like, are they in that corner doing something? I was like, what are you doing? He's like, dude, you want to play that? I was like, golf? He's like, yeah, we'll get outside. I was like, yeah, she's definitely not supposed to. You could split it.
It's way too wet.
I was not, well, yesterday, that was yesterday.
Yeah, I know.
That was in the middle of the day.
Okay.
It was so hard. Like, and on the.
But I think it was maybe meant to be given out.
I would want to. I'm considering it.
Okay, there you go.
Thank you, Ms. Evans.
Welcome.
I appreciate the homework.
Hey guys, you're welcome. Don't forget to do your online assignment. Mm-hmm.
But one day, I don't bring my Bible, it's the day we have homework with the book.